Hey Hux. We've talked about covalent bonds, and we've talked about how the electrons are shared in covalent bonds, as opposed to that they're given away or brought into the atom. Um, the most important thing is to understand, what does that bond structure look like? And so to do that, we're going to do what's called drawing covalent bonds, or drawing Lewis structures. Okay, so today we're going to talk about what the rules are for drawing Lewis structures and assigning formal charges. And by the end of this, you will be able to draw a Lewis structure for simple covalent bonded molecules. Okay, so these rules apply to most covalent bonds, not all of them. Okay, but for the ones that we really need to understand, this works fine. Okay, so what is a Lewis structure? A Lewis structure is a very simplified representation of the valence shell electrons in a molecule. Okay, so as an example, here is a Lewis structure, right? I've just put down I've drawn out the symbols for the elements that are in the molecule. I've represented bonds with lines, and I have represented extra electrons with dots. Okay, and so we're going to talk about the rules for that. Okay, so basically, this Lewis structure is used to show how the electrons are arranged around individual atoms in a molecule. The electrons are shown as dots, or for bonding electrons, as a line between the two atoms. So the lines and the dots are basically the same thing. The dots are electrons that are not bonded with anything. They're not being shared. The lines are electrons that are being shared. Okay. The goal is to obtain the best electron configuration. Basically, if you think about the octet rule, and formal charges need to be satisfied. So that means that all of the elements have that 8, except for hydrogen, which wants 2. Okay, and hydrogen is that exception. Okay, so step 1, determine the total number of valence electrons for the molecule. Okay, so yeah, we can figure out the valence electrons for each individual element, but now we need to do it for the whole molecule. It's pretty easy. You figure out what the valence electrons are for each of the elements, right? So carbon, there are 4, right? We get that from our periodic table. Oxygen has 6. Then you look at how many of them are there. There's 1 carbon, and in this case, there are 2 oxygens. So 2 oxygens. So I'm going to multiply the 6 by 2 because there are 2 oxygen molecules. So if I do that, I get 12. Then I'm just going to add them together. The 4 from the carbon, the 12 from the oxygens, and that's going to equal 16 electrons. That is the total number of valence electrons available in this molecule. Okay? Then we're just going to draw like a skeletal structure for the molecule. Basically, what we're going to do is we're going to put down, we're going to draw out the symbols for each of the elements, for each of the atoms, and draw single bonds, right? Single bonds are just one straight line in between. Okay? That central atom, the one that's usually in the middle, will be the one that can form the greatest number of bonds. Okay? Or it can expand its octet, which we're not going to look at. There are some special cases where you can go beyond 8, but we're not going to go there. Okay. So the big thing you need to understand is that this line, this one line, is equal to 2 electrons, 2 valence electrons. Okay? And then also for that center atom, C is always in the center, right? Carbon always goes in the center. And then hydrogen will never go in the center. It's always going to go on the outside. Okay? Those are just 2 simple rules that we can use to remember. Okay? Step 3, draw in the remaining valence electrons. So I started with 16, right? That's what I got from step 1. I used 4, right? So I have 2 electrons here and I have 2 electrons here. So I used up 4 of them. That means that I have 12 left over. I need to take those 12 and spread them out between the outside atoms, right? So the elements that are on the outside, not the inside one, but the outside one, spread them out so that you try to get 8, right? So here I have 2, 4, 6, and then that 2 is 8. Okay. Make sure though that you're only drawing them on the outside. Once you get to the point where all of the outside ones have 8, then you can add them to the inside. Okay? Okay. Then we're going to take lone pairs and we're going to split them and make them double or triple bonds depending upon how we move them. Okay? Basically, what we're trying to do is we're trying to make all of the atoms happy. Okay? All the atoms, again, except for hydrogen, want 8 electrons around them. Okay? All of them they all want 8 associated with them. Okay? Except for hydrogen. Hydrogen would be happy with 2. Okay? So here's our molecule our skeletal one from step 3. So if we count, we have 2, 4, 6, and then remember this line is 2, so that's 8. So oxygen is happy. Same on this side. But if we count for carbon, we have 2 here and we have 2 here. That's only 4, right? He wants 8, so he's not happy. Okay? So what we want to do is we want to make carbon happy. The best way to do that is to take pairs of electrons and move them in to form bonds. So I'm going to take this pair of electrons. So these 2 electrons are now going to become another stick. So now I have a double bond. I'm also going to take these 2 electrons and I'm going to move those in and we're going to have a double bond there. So now if I count, I have 2, 4. Remember, each stick is 2. So that's 6, 8 for the oxygen. They're happy. Same on this side. And then for the carbon, I have 2 from this one, 2 from that one. That's 4. And I have 2 from this one and 2 from this one. That makes 8. So now my carbon is happy. So when I'm looking at carbon dioxide, this is what that molecule would look like. It would be an oxygen double bonded to a carbon, double bonded to an oxygen. And that is how you draw covalent bonds. It's the easiest way to do it. Okay? And I'm going to be right back and I will show you how to do that with another example.